Good morning everyone, myself Devika, working as Assistant Professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today we are on the subject on W25C01 Basic Electrical and Electronics Engineering for 2023 regulations. In this presentation, it covers the basics of microprocessor, microcontrollers, and their architecture, and the 8085 microprocessor. Characteristics of microprocessor. A microprocessor requires external memory and input-output devices to functions. It offers high computational power and flexibility, and it's suitable for multitasking and complex applications such as computers. However, it consumes more power. Then microprocessor, difference between microprocessor and microcontroller. So microprocessor contains only the CPU and needs external components. So it performs arithmetic, logic and control operations, but depends on the external memory and input-output peripherals. Microcontroller. Microcontroller integrates CPU, memory and peripherals on a single chip. So it is designed for dedicated control applications. So microprocessors are used in general purpose systems, while microcontrollers are used in dedicated embedded systems. Then applications of microprocessor. So it is commonly used in personal computers and it found in workstations and servers. So it is used in high performance computing systems where complex calculations are calculated. This is the block diagram of 8085 microprocessor. Then microcontroller architecture. So microcontroller contains CPU, RAM, random access memory, read-only memory and flash memory, input-output ports, timers, communication interfaces, and analog to digital converter and or digital to analog converter. All components are integrated into one chip, making it compact and cost-effective. Then CPU, Central Processing Unit. So CPU is the brain of the computer system. So it registers, store and temporary data. So IALU, Arithmetic Logic Unit, performs arithmetic and logical operations. And it control unit manages instruction executions. In caching memory, improves processing the speed. And input-output units handle data transfer. Then accumulator in 8085 microprocessor, ALU in 8085 microprocessor. So accumulator is an 8-bit register used for arithmetic, logical and data transfer operations. Likewise, the ALU arithmetic logic unit performs operations such as addition, subtraction and then OR gate. So together they form the core processing section of the 8085 microprocessor. General purpose registers. The 8085 contains 6 8-byte registers B, C, D, E, H and L. These registers temporarily store data. They can also be paired as B, C, D, E and HL to handle 16-bit operations. Then program counter. So program counter is a 16-bit register and it stores the address of the next instruction to be executed. After executing an instruction, it automatically updates to the next memory positions. Stack pointer and temporary register. So stack pointer. The stack pointer is a 16-bit register that points to the top of the stack memory, and it is used during push and pop operations. So the temporary register stores intermediate data during the arithmetic and logical operations. Then temporary registers. And the flag registers in 8085 microprocessor. So it is the flag register is an 8-bit register containing 5 status flags. These flags indicate the result of the operations performed by the arithmetic logic unit. The flags are sign, zero, auxiliary carry, parity, and carry. Then types of flags in 8085. So sign flag, zero flag, auxiliary carry flag, parity flag, carry flag. So sign flag. So denoted as yes. So it indicates whether the result is positive or negative. Then zero flag. Set the instruction when the result is zero. Then auxiliary carry flag. It is used mainly in BCD arithmetic operations. Then parity flag. After any arithmetic or logical operation, if the result generator has even parity, that means it has an even number of 1 bit. So the parity register becomes set, that is 1. Otherwise it becomes reset, that is 0. Then carry flag. It is generated in the case when performing n bit operations and the result comes out to be more than n bits. Then this flag becomes set, that is 1. Otherwise it becomes reset, that is 0. Thank you.